Hey guys, so we're going to talk about 10.5 and what to do when you've got things inside of a circle. So for the most part, what we've been dealing with so far is like chords, intersections of chords, angles, etc. But now we're going to deal with mostly secants and tangents. So main thing here is we've got all of these kinds of diagrams. These are really all you're going to see at any point in the course of either any tests or in the class or anything else, right? So your first example is two secants that meet inside the circle, right? So the italicized word here is where they meet, right? So they're making angles inside the circle. The main thing here is what we're used to as central angles or inscribed angles, but these don't touch the center or the edge of the circle in any meaningful way, right? The vertex here is just flat out there, and we have to figure something out. So this guy is going to be really important, and there's a rule we need with him. The other three examples all more or less follow the same rule, and one is where you have two secants that meet outside of the circle. Another is when you have two tangents that are outside of the circle. Keep in mind, guys, these two pieces here, the two tangents up until they meet, are congruent to each other because that's going to come up as well. And then over here, where you've got one secant and then one tangent. But all of these essentially make an angle outside of the circle, and so there's going to be one rule, as opposed to the secants, which makes your angle inside of the circle. So correspondingly, what we essentially have is the angles inside the circle theorem and the angles outside the circle theorem. So if we consider our first example, here we've got angles inside of the circle. I went ahead and labeled the angle A and each of the arcs around it B and C, because those are what really matter. The main deal here is when you have either chords or secants going through and making an angle inside the circle that's not at a center, not at the end, it's just there, it's going to be the average of the two arcs. Right, so again, these angles are going to be the average of the two arcs made on either side. So we can actually write this out. We can say that when two secants or chords, go ahead and underline that last bit, when two secants or chords intersect in a circle, the angle measures of the intersection can be found by averaging the two arcs. Right, so we're going to average out the two arcs as a way of finding the angle measure in between. And remember, A is going to be both here and over here, because those are vertical angles. So another way we can write this out is that angle A is going to be equal to arc B plus arc C, all divided by 2. Right, that angle is the two arcs added together and divided by 2. So a good example here might be if we were to say this angle equals 20 degrees. And this bigger arc is, say, 60 degrees. And we want to know how to do that. Well, what we're going to find in the end is that whatever B plus 60, if I can use my keyboard, all divided by 2 is, that's going to get us 20. So a nice result here is that B plus 60 is equal to 40. And the only way this would work is if B is negative 20. So in this case, right, B wouldn't be able to function, but nonetheless, that's where we have it. Okay, so that's one example. Those are that's the angles inside of the circle theorem. Let's talk about the angles outside of a circle. So here I've got the example of two tangents, but really this can be any of the secants or tangents and secants, as long as you have an angle outside of the circle like this. So the main deal here is, like the last one, we're sort of dealing with an average, but now this angle is going to be equal to the major arc minus the minor arc divided by 2. Right? So now this is not addition, this is subtraction. So the big arc minus the small arc, major minus minor divided by 2. So what we can say about this one is that the angle that is outside a circle can be found by subtracting the two included arcs and dividing by 2. Right? So we subtract the two arcs, divide by 2 to get the angle. In this example, what we're going to find is that angle 2 equals PQR, the arc, minus arc PR divided by 2. So again, if we're going to make up some numbers, let's say this is 80. I guess it has to be more than 80, so let's say it's 189. And this is going to go ahead and be the difference between that and 360, so it's going to be 171. 2 is going to be 189 minus 171, then divided by 2. So we can do that as such, right? 189 minus 171, all divided by 2 equals, it's going to be 18 divided by 2 equals 9. So angle 2 would be 9 degrees. So that's really the main gist there. For just another example, if you're going to do this guy, for example, to find x, remember this angle is inside of the circle. So you would add the two numbers, divide by 2, and you'd get that x is ultimately 143 degrees, because it's these two added together, divide by 2. Whereas over here, my included arcs are 76 and 178, so I subtract, let me move it over, 76 and 178. So I would subtract the small one from the big one, divide by 2, and I would ultimately get that this is 51 degrees. All right, best of luck doing your practice problems, and see you guys tomorrow.